Welcome back to Hypothesis Testing Done Right, Part 12 of 14. In Part 11, we separated statistical significance from economic significance. Now, we name 3 errors so common and so corrosive that they deserve to be called out explicitly, the mistakes nearly every beginner makes, and that even seasoned researchers slip into. Learn to catch them in your own writing and in everyone else's. 3 errors are so common and so corrosive that we name them explicitly. Mistake 1. The p-value is the probability the null is true. We covered this when we defined the p-value, and we repeat it because it is the most frequent error in all of applied statistics. The p-value assumes the null and measures the data's extremeness given that assumption. It says nothing about the probability of the hypothesis itself. Reciting the correct definition until it is automatic is time well spent. Mistake 2. We accept the null. When a test fails to reject the null, we say exactly that, fail to reject, and never accept or prove the null. Absence of evidence is not evidence of absence. If Sam's t had come out at 0.4, the right conclusion is, this sample cannot distinguish the rule's edge from 0, not the rule has 0 edge. Maybe the edge is real but small, and 252 days is too few to detect it. A power problem, not a proof of nullity. A null that survives a low-power test has survived nothing. It was never seriously challenged. The confidence interval makes this concrete. Failing to reject means 0 is inside the interval, but so are many non-zero values you also cannot rule out. Mistake 3. Statistical significance settles the matter. We covered the seed of this when we separated significance from effect size, and here is the sharp form. A small p-value tells you an effect is probably not exactly 0. That is all it tells you. It does not tell you the effect is large. It does not tell you the effect is important, or robust to different choices, or causal rather than mere correlation, or that it will hold outside the particular sample you measured. Those are separate questions, and the rest of this book is largely about them, about magnitude, about robustness, about identification and causality. A star next to a coefficient is the beginning of an investigation, not the end of one. When you find yourself satisfied by a single significant result, that is exactly the moment to ask the harder questions the p-value cannot reach. Significance is a gate, not a destination. To summarize Part 12, 3 mistakes to never make. 1. The p-value is not the probability the null is true. It assumes the null and measures the data's surprise, and it makes no claim about the hypothesis. 2. We never accept the null. We fail to reject it, because absence of evidence is not evidence of absence. And a null that survived a weak, low-power test survived nothing. 3. Statistical significance does not settle the matter. A small p says only that the effect is probably not exactly 0, never that it is large, robust, causal, or real beyond your sample. Catch these 3 and you are already ahead of most practitioners. In Part 13, we confront the way a search across many tests quietly breaks everything we built: multiple testing and p-hacking.